Bolaffi was founded in 1890 as a philatelic business, and throughout the time it added a number of different collectibles to stamps. It is also possible that the company will have a future in vintage technology collectibles, and the Apple-1 is their quintessential epitome. Torino becomes, in fact, the center of the information technology history, the history of a revolution that is both Italian and global. I don't think there's another country where today you can find two Apple-1s.
We started with a preliminary examination of the board.
A visual inspection of the board, closely looking for any flaw or imperfection.
Broken tracks, badly welded joints, or other faults, also caused by aging. The first thing to do when you approach this board is to check the power supply.
The power supply stage on this board cannot be separated from the logic one.
The supply voltage for those integrated circuits was back then and still is 5 volts. If you go as far as 5.25 volts, that's enough to put the chips in serious danger.
Powering up these kind of devices without a prior test of its key components and of those ones that could have degraded over time can be quite risky and damage even the healthy parts.
If, when turning the power on, the power supply does not operate correctly, well, then the integrated circuits would be fed with more than a 5 volts current, frying immediately any chip installed on the board.
From an integrated circuit to a capacitor to the entire board, everything would be damaged.
It is necessary to remove all parts from the board in order to test all the power supply components without damaging the chips.
You could replace many of these parts, but finding vintage components today is an entirely different matter.
The microprocessor, the mighty 6502, is no longer available on the market, so you can only approach the collector's community and hope to find one that is still properly working.
Replacing vintage components with modern ones, even if the same model, is an obvious fake. From an historical point of view, we can say. Disassembling and reassembling operations can bring along two kinds of problems. A mechanical one, meaning that you can bend the pins when taking them out or putting them back in, or you could experience problems with electrostatic charges.
We helped out removing the integrated circuits from the board.
We made a very simple anti-static panel with some sponge rubber and aluminum foil, the whole thing properly grounded.
We used it as a place to store the integrated circuits so that they were securely grounded.
We also grounded ourselves wearing anti-static bracelets. The capacitors in this machine diagram work to rectify the supply alternate current, and they are the components most prone to degradation over the years. We had to warm them up slowly to avoid a sudden voltage shock that could have damaged them.
We charged the capacitors little by little. We started feeding very low voltage in order to warm up the liquid inside the capacitors.
One of the capacitors was rated for 25 volts working voltage. So then you have to reach slowly not more than 23 volts, making sure that the current always tends to zero. Hypothetically, if we were to find that we could not control the current rise, we would expect the capacitor to short pretty soon.
In 40 years, the inside electrolyte can dry up so that the plates are no longer isolated, which would lead to very bad performances or even to short circuits. Our capacitors, we found, were still working perfectly.
They used very high-quality capacitors. I mean, the manufacturer was one of the best on the market at that time. We owe it to the passion of people collecting and preserving, without even asking themselves why, for most of the things that have reached us are well preserved.
This device is a piece of history.
What happened next is what makes these devices unique. It's the value that we human beings give to them as symbols of a revolution.
It is right to go back to the very beginning of a story, fundamental in our times, and perhaps bound to somehow shape our future and for the rest of our life.
This fire did not spark in the Silicon Valley only. Computers, personal computers, conquered the whole world.
It's important to keep memory of everything human beings have made, and most of all, anything that brought pivotal changes for mankind.
It's part of our history.
These stories should strongly impress and motivate the new generations who are living a situation where, in my opinion, one needs to rediscover the value of working hard, strongly believing in something and striving to achieve it.
Then we had to test the diode bridges, but still without applying full input power. Instead, we used a power supply with full nominal voltage, but controlled current input. If you run a full current input, you could easily burn the tracks as well as the components. If instead you set your supply to a minimum current sufficient to start up everything, but not excessively high, you can always get immediately back to zero should any problem develop. Then we plugged the transformers in, and at that point we were sure that everything was working properly. By working with these devices, you gain expertise in using your fingers and feeling if anything is getting too hot, in using your nose to sense an unexpected smell coming from the board, and your hearing to check if you hear crackling noises, because in such a case it would mean that something is sparking.
The Apple-1 was not a hit, commercially speaking. In fact, it was immediately replaced by the Apple-2, which came with lots of improvements.
The impact on the industry was irrelevant. You see, they built few units just to be able to say, it works. It was only for a very tiny market. It was for the hobbyist market.
We're not talking about home users as we may be considered today. I mean, with our Macs.
They only built about 200 units, most of which were taken off the market as the Apple II came along.
The most interesting consequence was the release of the Apple II, which would become the machine that sold millions of units.
And in fact, it was advertised by stating, "The Apple II is here, ready to play, work, and grow with you."
We started powering up the oscillator, which is something like the beating heart of the device.
The oscillator is a quartz crystal set inside the device and represents the very heart of it, pacing it through its calculations. The quartz signal is of a relatively high frequency, so you have to use an oscilloscope in order to check if it is good enough.
We took care of checking out what our professors were doing, helped in removing some components from the board, and checked the pins were not damaged or isolated.
E verificare che gli zoccoletti appunto non fossero danneggiati o non conducessero elettricità.
We checked every power supply pin to make sure that they all worked, and then we made the lamp test on all of them, a test that shows if all power supply pins are properly powered.
Della lampadina che era appunto verificare se arrivava l'alimentazione ai pin di alimentazione degli integrati.
We ground tested the whole board. When the LED lighted on, to make sure the circuitry was not interrupted.
Verificare se il circuito era tutto connesso.
Jobs and Wozniak are the epitome of the Silicon Valley entrepreneurial duo. Wozniak was the one that, seeing the microprocessor, the 6502, had the idea to go and build a self-contained machine out of it.
When the 6502 came out, he built the machine and showed it to the Homebrew Computer Club. Sitting in the front row was another guy, a kid like Wozniak, who shared the same name, Steve, but had a different surname, Jobs.
Jobs' contribution to the Apple-1 is that of a father to his son. He dreamed what could have happened next.
Ne ha immaginato quello che sarebbe potuto succedere dopo.
The many solutions that I found while working on this machine are the ones with the footprint of very technology-savvy people. There are no redundant or useless elements, and everything is specifically designed for a perfect and precise performance of the device. If one cannot deny that this architecture is the brainchild of a genius by the name of Steve Wozniak, who has said, "I don't know how I did it, and I don't know if I could do it again. It must be remembered the future of the product was instead Steve Jobs' work."
This combination has made the Apple-1 and Wozniak's project very unique in the information technology history.
We went on putting the integrated circuits back on the board and slowly powering them on.
You move and you put back all the chips in place until the device is completely reassembled. There are 3 students of mine with whom I started a project 1 year ago to put back to work a small computer, a device dating back to 1975. They use in their daily life technology which is way ahead of this one here. These devices were completely cut out from the world. They could barely interact with their owners, so to speak.
It's been a great experience, interesting and motivating as I learned new things. We made once again exactly what Steve Jobs did back then.
I saw the enthusiasm and interest lights switching on. Now we are ready to turn on the device and check if we have activity in the data address bus, the data output of the microprocessor. Then we checked activity on the video output using our oscilloscope to find out whether there was any signal on that bus. There was indeed a signal, and that meant a good chance that by plugging in the monitor, we would have seen something.
The video signal was too unstable to properly drive the display, and so you got this rather worrisome flickering.
We went into panic for a moment, because when you plugged the monitor in, it couldn't sync. And so you got all these images flying around on the screen.
When I saw the flickering video, I thought, gosh, we've got a video problem. We lack sync on the video signal, so now we do have a problem.
I trimmed the video output level from the Apple-1 to the monitor, and that was it.
We just had a weak signal, but here Gabrielle's experience helped us out. We tried to enter some simple code to make sure everything was working right. The program that should have written the character set on the screen didn't work. We tried to load BASIC from the cassette interface, but it didn't work either.
Il caricamento del BASIC da interfaccia cassette non funzionava.
We couldn't find the right address of the memory locations.
Addressing means telling the microprocessor where the memory locations are physically to be found.
I am telling the device where to go find my code in the memory.
When we were writing the code, it fell in a great void, meaning it couldn't tell where to store it in the closet, so to speak.
The device was incapable of engaging itself with addressing.
It's almost like saying to somebody, in that drawer you will find those shoes and those shirts and so on. If my instructions are not correct, he will never get to the right drawer.
The machine, while perfectly operational, does not work in that it could well accept my instructions if only I would know where to send them. But too bad, this I don't know.
Most probably, we could have avoided this if we had the original addresses table.
There's not much information around for these kinds of connections, but luckily we had access to Marco Bolioni's Apple-1.
We had to look over his board, which we knew was properly set up.
We simply had to duplicate the working configuration for Bolaffi's board.
Sulla macchina di Bolaffi.
So we decided to simply set up the addressing jumpers in the same way.
The jumpers allowed the code I was writing where to go, read, and/or write in the memory. By creating this jumper, we were able to obtain unknown addressing. It's simply a piece of wire connecting 2 points.
As I can choose to have 4K or 8K, depending on how many chips I use, I must be able to tell the microprocessor, look, you will find some RAM there, or look, those bases are empty, disregard them. And this was done by putting these jumpers on the right places of the main board. Quite something different from the, plug and play. So the machine was fully operational, and we only needed to make it work as we wanted. And of course, our code worked out beautifully. The characters dumped to the display too, and we also managed to load all the instructions in BASIC and to write some catchy phrase for the owners who were quite happy with it.
E fa scrivere qualche frase d'effetto per I proprietari che sono rimasti molto contenti.
It has been a successful experience. Our Apple-1 is definitely in great shape.
Chiaramente funzionante, senza nessun problema.
Un'emozione pazzesca perché immaginarmi le
It's
sensazioni.
quite a great emotion to imagine the sensation of those two kids, in their garage in the valley. They must have felt the same emotions we are experiencing today looking at these parts, connecting them together and bringing a working machine back to life.
E dar vita a una macchina che funziona.
It's definitely a sensation in the pleasure sphere. Somebody said, the difference between men and boys is the price of their toys. To have gone back for some time to the machines of my childhood. Well, childhood, so to speak. It's almost like fishing out the old photo album and looking over old faces that you forgot to have known once. I cannot think of all the times back in school when rumors were circulating of this personal computer arriving here in Italy. We didn't know anything.
By looking at it, I can see a group of young kids who believe in a project and are strongly motivated to complete it, up to the cost of selling some of their cherished properties to make it happen.
We're here, 40 years later, well, a little less than 40, achieving the same goal. I can imagine Steve Jobs and Steve Wozniak in their garage experiencing the same sensations as we do today.
Le stesse emozioni che stiamo provando noi oggi.